This report explores the scientific discovery of the Planck luminosity, a theoretical ceiling of power that represents the brightest possible state in our three-dimensional universe. Is there a maximum limit to how bright the universe can get? Scientists have determined that the answer is a definitive yes. There exists an ultimate power barrier known as the Planck luminosity, a threshold so intense that its release would instantly overshadow every star in the observable universe. To grasp the sheer scale of this limit, one must look at the cosmic ladder of power. While a common light bulb operates at 10 watts and a nuclear explosion peaks at quadrillions of watts, these are insignificant on a galactic scale. Even our Sun, burning at 10 to the 26th power watts, is dwarfed by a supernova, which releases 10 to the 36th power watts, enough to rival an entire small galaxy. The most powerful known phenomena are quasars and the violent collisions of black holes. When two black holes merge, they tear the fabric of spacetime, reaching a power output of 10 to the 49th power watts through gravitational waves. Yet, even this does not reach the ceiling. The ultimate limit is 10 to the 52nd power watts, a figure thousands of times greater than the combined light of every star in existence. What prevents the universe from becoming even brighter? The answer lies in the delicate balance between Albert Einstein's theories and the nature of gravity. On one hand, the speed of light is the universal speed limit for energy. On the other, if too much energy is concentrated in an incredibly small space, gravity collapses that region into a black hole, preventing light from escaping. The Planck luminosity is the critical tipping point where these two laws meet. Perhaps the most shocking revelation occurs in the mathematical derivation of this limit. Scientists discovered that the formula relies solely on the speed of light and the gravitational constant. The fundamental constant of quantum mechanics, known as the Planck constant, completely disappears from the equation. This suggests that the maximum brightness of our universe is a purely classical physical phenomenon rather than a quantum one. Further calculations reveal a profound truth about the nature of reality. This limit remains classical only because we live in a three-dimensional world. In a two-dimensional or four-dimensional universe, the ceiling of brightness would be dictated by quantum gravity. Consequently, the three-dimensional structure of our universe appears to have written this simple, majestic physical boundary into the laws of nature. It is not just a limit of power, but a fundamental signature of the dimension we inhabit.